Welcome back, folks. In today's class, we will continue talking about chapter number 6, and we're gonna start with chapter 6.4. And in this, we will talk about the sum of cubes and the difference of cubes. So the formula, one more time, I'll write it: x cube plus y cube is equal to x plus y, and x square minus xy plus y square. This is the formula for x cube plus y cube. And the formula for x cube minus y cube is equal to x minus y, and this will be x square plus xy plus y square. This is the formula for difference of cubes. Now, let's look into a question based on these formulas. So the question is ax raised to the power 5 minus ax square. Now, in this question, if I look at carefully, this does not look like this. Now, first of all, whenever you have any algebraic equation in front of you, first thing you need to do is to ask yourself, can you reduce it? And when you're going to think about this, when the numbers are in the fraction form. Fraction form means if it is like this: ax raised to the power 5 divided by x raised to the power 3 minus ax square. So this kind of a number is in the fraction form. Can you reduce something? So in this case, yes, you can reduce it, so reduce it. But now the question given to us, it is not in a fraction form. So that goes out of the window. The second thing comes into the picture is, can you take something common? So between the two terms, so in these two terms, can I take something common? Yes, I can take common, that is x square. If I'll take x square common, the leftover will be, actually I can take ax square common, this leftover will be x cube minus 1. Now this has started taking some kind of a shape. I can convert it into actually this form by putting a cube on top here, because 1 cube is 1. Now ax square will stay as common. Oops, 1 second. Now ax square is common, and then a cube minus 1 cube, I can write it, x cube minus 1 cube, I can write it as x minus 1 x square plus x times 1 plus 1 square. Now the final answer will be ax square x minus 1 x square plus x plus 1. This will be my final answer to the given question. So hopefully you were able to understand how we're gonna solve these kind of question. So another question can be 4 over 3 pi r raised to the power 3 minus 4 over 3 pi r raised to the power 3. So this r is different from this r. One is a capital R, another is a small r. So first of all, I'm gonna ask myself, can I reduce it? No, I cannot reduce it. But can I take something common? Yes, I can take something common. What can I take common? 4 over 3 pi, and the leftover will be r cube minus r cube, and I can apply the formula on this one. So 4 over 3 pi, and then I can write it as r minus r square plus capital R times small r plus r square. This will be my final answer to the given question. All right, so this was about the cubes. Now we're going to go to the fractions. So for example, the question will look like this: x square times x minus 2 and divided by x raised to the power square minus 4. Now first thing, remember what did I tell you whenever you see the number in the fraction form? So first thing you have to do is to, can you reduce it? To reduce it, you have to apply certain operations on this one. So this is x square minus 4. Can I convert it into some other form so that you can reduce it? So I can write this equation. The top will be written as it is, but the bottom I can write it as x square minus 2 square. This I can clearly see I can convert it into difference of squares. Again, one more time, if you see a negative sign and you see a square, there will be some term, maybe 9, maybe 16, maybe only 1. Always try and think, how can you convert it into difference of squares? So sometimes the number may be written as 5 x raised to the power 2 minus 45, something like this. Now this negative sign and this square is giving you a hint, you can convert it into the difference of squares. How? First of all, you will take 5 common, x square minus 9 and then now you can convert it into difference of square. So the idea is, as soon as you see a square and a negative with it, and now there are only two terms, then you should always think of converting it into difference of squares. All right, so this is x square and then x minus 2, and this will be x minus 2 and x plus 2. Now, before I start solving this question, whenever the numbers are in the fraction form, we have to find the non-permissible value. Non-permissible values. What is non-permissible value? It means that all those numbers for which denominator will be equal to 0. Basically, what you are doing is, whatever is in the denominator, you will put it equal to 0. So first of all, I'll put x minus 2 equal to 0, and then I will also put x plus 2 equal to 0. Now from here I will find the value of x. So x value will come out to be 2, and x value from here will come out to be negative 2. So I will write it as x cannot be equal to 2 and also cannot be equal to negative 2, or you can write it x cannot be equal to plus minus 2. Now, this is important because when you will be finding the value of x, in this question there was no equality, the like something like this has no equality sign into it, so we don't need this thing that much. But this is always a good habit to find the non-permissible value, because whenever you have an equality and you are trying to find the value of x, at that time you will need this, which we will talk about in detail later on. So for the time being, whenever you are finding whenever you are simplifying a fractional question, always find the non-permissible value. How you find the non-permissible value? By putting the things, whatever in the denominator whatever is in the denominator, put that equal to 0, and find the value of x from there, and those values are non-permissible values, that x cannot be equal to those values. All right, coming back to the question now. So I can cancel x minus 2 and x minus 2 from here, and now I'll be left over with x square upon x plus 2. So this is the final answer to simplify this. Now the next question is, if I wanted to reduce a fraction x square minus 4x plus 4 upon x square minus 4. Again, I can clearly see the bottom. I can easily convert it into the difference of square, x minus 2 and x plus 2. Now can I convert this one into the factor form? Yes, I can find out the factor. I've told you how to find the factors in the previous video, so go and watch that video. I'll one more time do it here also, so that you can brush up the skills, but please make sure you watch the previous video also. So I'll place 1. If there is nothing in front, I'll place 1 here. So 1 times 4 is 4. Factors of 4 is 2 and 2. And now I will find the two numbers whose algebraic addition is equal to negative 4 and whose multiplication is equal to 1 times 4, which is 4. So those two numbers will be 2 and 2. So I will write it as actually negative 2 and negative 2, because negative 2 and negative 2 will give me negative 4 when I'll add them, and negative 2 times negative 2 will give me 4, which is a product of 1 and 4. Now I will rearrange, or shall I say, I will convert this 4x into negative 2x and negative 2x plus 4. And now I'll start taking x common from the top, and then x minus 2 minus 2 x minus 2, and then on the bottom x minus 2 x plus 2, and then x minus 2 here, x minus 2 one more time, and on the bottom x minus 2 and x plus 2. I can cancel x minus 2, one of them, and left over is x minus 2 x plus 2, non-permissible value. Now I've already solved this question, so will I take this one to find the non-permissible value? No, I have to take the non-permissible value from the beginning before solving it. So non-permissible value will be x minus 2 equal to 0, x plus 2 equal to 0, x cannot be equal to 2, x cannot be equal to minus 2. So these are the non-permissible value in this question. All right, so let's look into another question. So the next question is x square minus 1 and 1 minus x. And in this, if I simplify this one, the top, it will be x minus 1, x plus 1, and upon 1 minus x. Now what can I do to the bottom so that I can cancel something out? So what I'm going to do is I will I will take a negative from here. So if I take the negative from the bottom, then before even I take the negative, I need to make sure that I find the non-permissible value. So I'll do that later on. So coming back to the thing which we were talking about, I'll take the negative common so that I can cancel one of the terms from the top and the bottom. So if I take the negative common, it will become x minus 1 and with the negative. So what you can do is, to understand this, if you rearrange this negative again inside the bracket, you will get this term. Okay, so I've taken a negative out, so x minus 1, x plus 1, and then I will cancel this one and this one, and still there is negative. Negative means there is, you can always place 1 here. So x plus 1 over negative 1 will be my number, and I can bring this negative on top by writing it this way, minus x plus 1, or you can, this is of a correct answer, or minus x minus 1, you can write it this way also by distributing this negative to the two terms. Both are correct answers. Now coming back to the non-permissible value, so 1 minus x equal to 0, so x goes on the other side, equal 1 equal to x, so I will write it x cannot be equal to 1. So that is the non-permissible value. Now, the next thing is, let's do one more question. 2x raised to the power 4 minus 128x and divided by 20 plus 7x minus 3x square. Now, again, I wanted to simplify this. What can I do with the top and the bottom? Can I take something common? I can see there are two terms on the top. There is 4, means I can convert it into square form and then apply the difference of squares. That's my hint. And the bottom, I can convert it into the quadratic equation. So I'll take first of all from the top 2 common. And is there anything I can take common? I can take another x common. So I'll take x common. Now I cannot convert it into the square. Now the story is different. As soon as I saw, I was thinking of converting it into the difference of squares, but now I'm converting into the difference of cubes, minus 64. Now the leftover on the bottom, what I can do is I can rearrange the term, 3 negative 3x squared plus 7x plus 20, and then this will be 2x. The top will be x cubed minus I can write it as 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So 4 cube I can write it as, and then I can take the negative common from the bottom and write it as 3x squared minus 7x. If I take the negative outside the bracket, I have to change the sign of every term inside the bracket. Okay, so let's change the signs inside the bracket. Negative 7x, negative 20. And now the next step will be, I will write the formulas for x cube minus y cube. So this will be 2x common, x minus 4, and this will be x squared plus 4x plus 16, and then divide. I will take the minus 1. Minus means you can write a 1 also here. Yeah, so minus 1 outside, and the for this one, what will be the factor? I will 3 times 20 is 60. So factors of 60 is 2 times 30, 2 times 15, 3 times 5, and my factors will come out to be, my factors. The factors will be 2 times 2 is 4, 4 and 15. Does that make the answer to 7? No, that doesn't give me. 2 times 2 is 4, 4 times 3 is 12, 12 and 5, 12 minus 5, that is 7. Surely that will give me the number, but this will be minus 12 and plus 5. So 3x squared minus 12x plus 5x minus 20, because what do I want? This is negative 20, negative 20. So negative 20 times 3 is actually negative 60. So this is, the product should be negative 60, and the algebraic addition should be negative 7x. All right. So now 2x x minus 4, and this will be x square plus 4x plus 4x plus 16, and then on the bottom negative 1, and this will become 3x common x minus 4 plus 5 common x minus 4, and then I will compile the terms 2x x minus 4 and x square plus 4x plus 16. And if you can convert it into the simpler terms, try and reduce that also by taking the factors. If you cannot, then leave it as it is, 3x plus 5, and this will be x minus 4. And can I cancel something? Of course I can cancel something out of it, and the leftover numbers will be 2x and x square minus x square plus 4x plus 16, and on the bottom negative 1, 3x plus 5. This negative you can move it on the top also. You can move this negative 1 here. Now this will be my final answer. Now another thing I have to do is to find the non-permissible values. Non-permissible values will be, I will put whatever is in the denominator equal to 0. So this will be 3x plus 5 equal to 0 and x minus 4 equal to 0. So x, from here you can say x cannot be equal to 5 over 3 negative, because this goes on the other side becomes negative, and x cannot be equal to 4. So these are the non-permissible values. Never forget to find the non-permissible values. Now, I think I've done enough questions for you guys to understand what's going on in this topic. I will highly recommend you guys to do some of these questions. So one question I will do uh, also one more time. So if the question looks like something like y square minus x square, and this is 2x minus 2y, I will encourage you guys to pause the video and try and do it yourself. All right, so now this is y square minus x square can be written as y plus x, y plus x, y minus x. And then on the bottom, you will take 2 common x minus y. Now, the top and the bottom look similar, but they are in the reverse order. So I'll take a negative outside from the bottom. Negative 2, it will become y minus x, I will write. And then I will write the top as it is, y plus x and then y minus x, and I can cancel y minus x from here, and the answer will be y plus x upon negative 2. What I have done one more time, I have taken the negative sign out, negative 1 out here, 2 times negative 1 here. I will write it as, means I'll interchange the signs in the bottom, y minus x. Think about this. If you rearrange this goes in, this becomes negative, this multiplies with this becomes positive. So always whenever you're confused what I've done, so you write it and rearrange it, and you will be able to understand that you should be able to go backwards with whatever next step you have done. Okay, so I've just taken a negative outside the bracket in this given question. All right, so I will highly encourage you guys to do some problems from chapter 6.5 especially. And now I'm going to jump into chapter 6.6, and I will talk about the multiplication of the multiplication division of the fractions. So I'll talk about simply what is the fraction. So if the two numbers are 2 over 5, then I'll write it divided by 3 over 5. Now, which division counts the most in this one? This division will be counted as the main division. So I'll write it as 2 over 5 divided by 3 over 5. Whenever the numbers are written in this way, you will convert this division into multiplication and flip the second term, not the first term, second term, 2 over 5 multiply by 5 over 3. And now you can reduce it. Your final answer will be 2 over 3. Same process, you're going to do it in the algebra also. So let's look into a question on the algebraic form. So 3x minus y and divided by x minus y square and multiply by x square minus y square and divided by 6x plus 9y. Now here it is in multiplication, you don't need to change it. This only the sign in between you have to change it if there was a division sign. Let's say if there was a division sign, you would have convert it into multiplication by flipping the two terms. Now here it is the right away there is a multiplication sign, so I'll leave it as it is. Now I'll try to reduce the numbers. Now this is x minus y whole square, this is x square minus y square. So again, one more time, one basic which I want to talk about, x minus y square. Please don't start distributing these terms like this. This is wrong. This is wrong because there is a negative inside. This is I talked about in the last video also. So this I can only distribute it if they are in multiplication, then I can distribute it. There should not be any negative sign in between the two algebraic terms, negative or positive for that matter. All right, now but what I can do is I can cancel this x minus y, one of the x minus y, with the top one, and here I will write it as 3. This will become a difference of squares, x minus y and x plus y, and then on the bottom this is x minus y, and here I can take 3 common out of this, x plus 2x plus 3y, and now I can cancel x minus y and then 3x plus y upon 3 here, 2x plus 3y, and I can also cancel this 3, and this will be my final answer. The leftover will be the final answer. So this is the question on multiplication. Now another question which I'm going to take, that is on the division. So if the question looks like x plus y and divided by 2x plus 2y, and this divided by 6x plus 15y. Now what I'm going to do in this kind of a question, so I'll leave it as x plus y, the first term as it is. I can place 1 in the denominator so that there is no confusion. This division will convert into multiplication, 6x plus 15y upon 2x plus 2y. Now can I reduce the fractions into smaller terms? I can reduce the second fraction for sure. I can what I can do here is I can take 3 common. This will be 2x plus 5y, and then on the bottom 2 common, x plus y, and then I can cancel x plus y and x plus y. The leftover is 3 over 2 x 2x plus 5y. This will be my final answer for the question. And again, if you have to find the non-permissible value, so I'll put 2x plus y equal to 0. 2 goes on the other side. Oops, equal to 0, and then x plus y equal to 0. X cannot be equal to y. That is the non-permissible value for given question. All right, so I will highly encourage you guys to simplify some of these questions. I've given you the basic procedure, how to solve the questions, and yeah, try and solve some of the algebraic questions. The whole idea is you should be able to always try to reduce the terms. That's the whole essence of when you are solving these kind of a question. I'll do one more question. So the question is like if it is x raised to the power 4 minus 9, and this is x square divided by x square plus 3 whole square. Now if the question is in front of this looks like this, now I cannot make any formula out of this. This is not straightforward question. So what I need to do is always ask myself, I'll take a pause and ask myself, how can I convert it into some other form so that I can reduce it? So I can write it as x square. First of all, before I start reducing, also x raised to power 4 minus 9 divided by x square. This division will convert into multiplication. I'll place 1 in the bottom. I can write it as x square plus 3 whole square. Now what can I do with the top? I will convert it into difference of squares. Square minus 3 square, right? Multiply by 1 over x square plus 3 whole square and divided by x square. So what I'm going to do from here is x square minus 3 x square plus 3 and divided by x square, multiply by 1 upon x square plus 3 whole square, and one of those terms I can cancel from here, and left over will be x square minus 3 and x square plus 3. that's how I can find out the uh, answer. So this will be my final answer for the given question. Let's take one more question. Uh, Somehow I'm enjoying this question, so I keep on doing more and more questions. And it's 25 upon 4x square divided by 4x plus 10. I will encourage you guys to pause your video and try and do it yourself. Think about it. What will be your strategy? Okay, welcome back. So 4x, I can again convert this top into the some kind of a difference of square. Before that, I can convert this into multiplication and flip the second term. So 4x square minus 25 upon 4x square multiply by 8 upon 4x plus 10, and then I can reduce this top, so I can write it as 2x whole square minus 5 square and divided by 4x square multiplied by 8 4x plus 10. Now this will become 2x minus 5 2x plus 5, and on the bottom 4x square and multiply by 8 upon 4x. I can write it as 2 common, 2x plus 5. I can write it like this. See, this 4 times 1 is 4, 4 times 2 is 8, and then this I can cancel it with this term, and now 2 and 2 reduces. My final leftover answer is 2x minus 5. So that's how we're gonna solve these kind of questions. Okay, so hopefully you have an idea how to solve these questions. In the next video, I'm going to talk about the addition and subtraction. Until then, goodbye.